Today, I would like to discuss or share about how to memorize the differentiation of trigonometric equation. If you still remember, we have already discussed about this hexagon. Okay, so how about the hexagon if you would like to apply the derivative? Okay, so first thing is I would like to divide this hexagon into two parts. Alright, so I divide the two parts. Where is the right hand side? We said that this is a positive differentiation. For the another side, where is the left side, we see that this is a negative differentiation. Alright, next is to apply this. Okay, I put down this power 2. Okay, for the identity, for our 777, okay, so you have that this will become the power 2. But for this case, we have only the same kaki sahaja yang kuasa 2. Okay, sekarang anak-anak murid, mari tengok macam mana Miss buat the differentiation of the trigonometric function. Okay, for example, let's say that I have one question. Okay, differentiate the following. Okay, find the dy dx of the following. Okay, first question. Let I have y equals to sine x. Alright, how to differentiate the sine x? Okay, I would like to use this hexagon where I use this one. Differentiate of the sine, the answer is, okay, differentiate of the y is dy dx. Differentiate of the sine, we're going to have that the sine is located to the positive quadrant, okay, so positive side. So we have that this is a positive cos x, where you will have that this is a dy dx equals to cos x. Second example B, how to differentiate y equals to tangent x. Okay, we use this hexagon. Differentiate of tangent x will turn to the dy dx equals to tangent is located at positive quadrant. So this is a positive, okay, positive. The answer is secant square x. Now dy dx equals secant x. Let's move on to how to differentiate cotangent. Okay, cotangent x. So we use this is the part of the cotangent. So differentiate of y, we have dy dx. And cotangent x, cotangent is located on the left side. So you have negative. And the arrow turn to the negative, where is cosecant square x. Now, how to differentiate cos x? Okay, we use let's refer the head or the arrowhead of the red color to differentiate the y. So we have this is the dy dx. Use the same of the arrow where is a cos. So you have to vice versa in another direction. Cos x locate to the left side. So we have that this equals to negative sine x. Now, let's differentiate for secant x. Remarks here, this is a for secant x, where is secant power of 1. But from this hexagon, you have a secant power of 2, so we can have that this is secant x times secant x. Alright, so let's flip back this arrowhead. So you will have that to differentiate the secant x, okay, you gotta have that is a tangent, and these are at the positive side. So we have that y, now this is dy dx. Now you have only single secant here, so we have to repeat back. This is secant move to the tangent. Okay, so we have that this is secant x, then tangent x. Since the secant x is at the positive side, so this is a positive secant tangent. Now you can have that this is a dy dx equals to secant x, then tangent x. Next is we have to know how to differentiate the cosecant x. Use the same concept, the secant square. So what we have to do when the secant square means this is equals to secant x, next what is times to the cosecant x. Okay, next is we just flip over the arrowhead. Okay, careful. Now we have the y, so let's differentiate the y here. So we have dy dx. To differentiate the second x, now these are located at the left side. So you have the negative and flip over again the cosecant. What is now? You repeat back the cosecant. So you have that is equal to cosecant x. Next is cotangent x. Alright, so now we have learned how to use the hexagon case. And total up together, you have 6 formula how to differentiate the trigonometric equations. Alright, it is very simple. To be so much worried, what you have to do, let's use this brilliant hexagon.